Hi guys, today I want to discuss this problem. LeetCode 995 is finding the minimum number of k consecutive bit flips. So we are given an integer array nums under integer k. A k bit flip is chosen a subarray of length k from nums and simultaneously changing every 0 in the subarray to 1 and every 1 in the subarray to 0. Then the minimum number of k bit flips required so that there is no 0 in the array. It is not possible to return -1. A subarray is a contiguous part of an array. So we have to find the minimum number of k bit flips. For example, k is 1 here. When k is 1, there are 2 zeros. For each 0, we can go and flip it. So there is first 1 0 at index 0 and 1 0 at index 2. And we can use k flip 2 times. Here k is 1, so here we are fine. So let's say second example, it is 1 1 0 and k is 2. No matter how we flip subarrays of size 2, we cannot make the array become triple 1 because there is only 1 0 there, which is at index 2. We have to flip it to 1. That means we have to start the flipping operation at index 1 because you cannot start the flipping operation at index 2 because there are no more indices after that, which means we have to start flipping at index 1, but index 1 is already 1, which makes it 0 and 1. If we do it 1 0 1, it will become 1 0 1. And now the 0 has come in the middle, which is at the index 0. Now if you want to make that 0 1, we have to flip from the starting. That means you have to start from the index 0. So again, if you do that, then index 0 will become 0 and we came to the same problem. So there is no answer for this only. So let me just explain with an example. Triple 1 0 1 0 1 1 0. There is one more example. Triple 1 0 triple 0 1 triple 0 1 0 double 1 0 0 double 1 0 and k is 3. Right now we have to start the set each initially we would be at the index 0 and then we can either flip this, start flipping from here, or we cannot flip from, let's say if there is flip here, there is no flip here. We can flip only if there is, let's say, array of size I, there at index I. You can only flip there are at least k elements remaining after the I, otherwise we cannot flip. So let's say when we're at f of I, we can flip only if there is I plus k should be less than the n, which is the length of the n is the length of the array. Now so we'll keep on doing like this. It will become f of I plus 1, f of I plus 1. but the state will change when it goes to f of I plus 1. Array state has changed, right? Now it will have a different array here, and it will have a different array here. Why? Because we applied a flip operation on starting from I until I plus k. So this array has flipping operation enabled. This array has does not have any flipping. Uh, So what do we do? Cannot represent. What is the array length here? Can it go? Array length is of size 10 power 5. So I think it's not feasible to do like this. But if you do this, so there are multiple ways to go like this, and each time we have to carry array along with I, along with the index that we're working on. We also have to carry the array. So it will be of order of 2 power n calls, and also while applying the operation, it will be order of n. So order of 2 power n into 3n. Can we optimize it better? Can we optimize this better? Can we optimize it better? We can optimize only if there are any redundant calls. That might be possible that we might have redundant calls. Is it possible? Yeah, we can do one optimization. So let's say when we are doing any flip operation at I, when we're doing flip operation at I with array, when we're doing flip operation, we took a decision to flip here. That means we don't need to go to f of I plus 1 instantaneously. We can instead go to f of j and with modified array, where j is the position such that I till j all elements will have 1. So in all, once we do the flipping operation, if all the elements from I include unto j, not including j, we have 1 as their element, then we don't need to flip them, right? We can directly pass it. Similarly, when there is nothing here, we cannot do anything. We just need to go to f of I. So this will go only if current node yeah, we can only choose this direction only if I a of I, only if a of I is 1, then only we can take this. Not like only if a is 1, we don't need to take always no approach. We can also take yes approach, but there is this liberty whenever we choose. Anyway, I think this does not look like a great optimization. In the worst case, it will be still be. Worst case, then it will be till order of n and 2n. Nothing changed. Can I do it better optimizations? Can I optimize it better? Uh, can optimize it better only if there is something technical. Otherwise, it's not even. So one can make it better. So we are starting from here. We have to go like this. When there is 0, we have to pakka. We have to damn sure that we know that we have to flip here. Here we may or may. Yes or no, it's our choice. So when there is 0, we have to flip. When there is 1, we have to flip. Or we cannot. We may flip or we may not flip. It's our choice. There are two options there. Hmm. So what do we do? This is giving the optimized answer. Yeah, because we will find all the possibilities and then giving it. So is there a creative way of doing it? Let's say I'll divide the array into. Let me just copy some. So let's say this is the array. We try to divide the array into k parts. Parts of size k. That means let's say k is 3 here. I will divide it to like this. So what? When we divide it, I think it doesn't look like a better approach. I'm getting clue here. Let's say how many possibilities would be there for n elements? There can be order of 2 for n possible summation. So for an n-sized array, there can be order of 2n possible arrays when we apply flip on there, right? You can apply flip anytime, anywhere. That means it can result order of 2 power and order of 2 power and 2 power and possible arrays. Hmm. There is order of 2 power and then the input will not be containing 10 power 5. I guess there is something wrong here that with the way we are doing this problem. There is definitely a polynomial solution for it, otherwise the input will not be 2 power n. Uh, mm, then we have to think in a better way. Let me try to think in a better way. In case 3, I will flip here. When I flip here, is there anything important thing we are missing here? Let's say I will just flip whenever I see 0, 1, I will just skip. For example, this one I saw 0 initially when I will start flipping 1, 1, 1. Then I got 1, I'll just pass it. Then I start 0, I'll flip it. It will become 1, 0, 0. Then I again saw 0, I'll flip it. Just write it. I think array is so confusing here. I just write the index. So 0, 1, 2, 3, 4, 5, 6, 7. Now I'll just write index 0, 1, 2, 3, 4, 5, 6, 7. So when I see 0, I'll just flip it. Flip, flip, flip. 1, flip, 1, flip. And then I saw 1, I'll just keep it. And then I saw 0, and then I will flip. So it will be 1, 0, 0, 0. But you have to again flip it starting from 5. So again flip it. You'll have 0, right? When you again flip it, it will become 1, 1, 1. So how many are there now? 1 flip. So total 3 flips. It looks like this is a greedy approach. It looks like it is working, right? So in this way, the time complexity would be order of n into k. Is it giving the better answer? Is what we know? No. You can try implementing this. Let's try implementing this and then see what does it say. Can we do it in better than order of n into k? We can. I think we can do better than this because whenever I'm at this position, order of n into k, whenever I know, I'll just take the same example: 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, then 1, 0, 1, 1, 0, right? 8 elements. Whenever I know that I'm doing a flip operation on 0, I have to flip all the 2 elements until this position. I don't need to do that flipping in this at the same time. I'll just maintain a stack. stack until what position I have to flip. So the stack will contain something like, let's say this is the stack. The stack I'll insert a flip address until j, flip flop until k, like this. Should it be stack or it should be a queue? I'll maintain a stack or a queue. Okay, the expiration entry first one has to come first out, right? It has to be FIFO. I think you have to insert a queue here. The queue should be of type what is the J? What is the K? What is the L, like this? And then there is an entry, it is until J we have to flip. And then we keep on flipping. Whenever we flip, we just put an entry here to the last end of the flip. Let's say we started at index 0 and it is index 2. This flip is valid for index 2. Then whenever I start with flip at 0, I'll insert an entry in the queue saying that there is a flip operation is going on until 2. Same thing. Let's say if I insert a flip operation at index 1, and I'll say there is a flip operation which is going on until 3. Whenever we saw, once we reach the index, right, and then we just prop, we just prop. In this way, we know what is the... One second, I have to... So I came back. My question is, now we're thinking about can we make that order of n k into 2 order of k, right? Order of n. Can we remove the k? Is the question. On approach, we are talking about is having a stack. Having a stack will help us. I think I got the idea now. I'll have a stack of all the indexes. Let me just so whenever let me just explain here. So whenever there is an entry 0 1 2 3, so this is index, right? 0 1 2 3 4 5 6 7 8. These are index, right? Now I have to start a flipping operation at 0 index. Then I'll have an entry in the stack. I'll have an entry in the stack saying there is a flipping operation going on. It has to go until index 2. Okay. Now the stack size is what? Size is 1. Then I'll come here. When I come here, I'll see what is the size of the stack. Size of the stack is, if it is odd, that means there is cumulatively there is a flipping operation here. You have to understand that properly. So let's see. Now it has become 1, right? Now it has become 1. First index has become 1. Get it here. And we are seeing the size of the stack. Size of the stack is what? Size of the stack is 1. When the size of the stack is 1, which is an odd number, that means odd number of flips, which is an odd number of flips which are going to be applied on the index j. Index j is 2 here. Odd number of flips applied on 0 will result in 1. What I mean to say is 0 flip operation on 1 flip will become 1. 0, 2 flips will become 0 1. 0, 3 flips will become 1, right? It's like XOR operation. So there has to be odd number of flips if you need to really flip it, right? So then I know since it is odd number of flips in the stack, our size is 1, which is odd. I'll flip it to 1. Then I have 0. Then I'll come here. Before coming to next element to 2, I'll see you have to pop elements from the cube. There is nothing to pop because previous index is 1. At index 1, we don't need to pop anything. When you're done with the processing of index 1, if there is an index 1 here, we'll pop, otherwise we'll not pop. We came to 2, there is a 0 here, and then again we see the same thing. Size is 1. Size is 1 means there is a flip operation here, which is odd. That means it will be changed to 1. Okay, now we are coming, we'll go to next index 3. When you go to 3, we have to pop the end, pop the entry from the queue because 2 is the last index. It has to be applied on. Now the stack is empty. Stack is empty. We come to 3. 3 is having 1. We don't need to do anything. We come to 0. 0, we see there is no resulting, there is nothing in the stack. That means there's no flip pending to be done here. So we just flip it. We just flip it. And the flipping operation has to go until 6, right? I'll insert an entry 6 in the stack. That means the size will become 1. And then this entry will go into be 1. Right? How many flips you have done so far? 2. Then we'll go to next index. Before going next index, you have to pop any element that are in the queue. So there is nothing element which is less than or equal to 4 here. So we don't need to flip anything. Then we'll go to 5. At 5, you see 1, but that might not be actual value because there is a entry in the queue which is of size 1. So the real value is here is 0 because there is 1 here in the array and there is 1 in the array and there are odd number of flips in the queue. That means this becomes 0. The resulting current value which is it's holding is due to the previous flips which are pending at this position is 0. So actual position here is 0. Now after applying the pending flips. Now what you have to do, you have to make this again. You have to again flip it to make it 1, right? So in order to flip it again, you have to again start a flipping operation from here. You have to, if you start it, it has to end at 7, right? I'll insert an entry in the queue. A size will become 2. A size will become 2. So now this will become 1. I'll go to the next index. Before going to the next index, I'll see if there is any entry with 5. There is no entry with 5. So I'll go to next index. I'm at index 6. And I'm at index 6. There is 1 here and then size is 2. So 1 is there and even flips are there. Even flips are there, so it will stay intact. So actual value will be 1 only after applying the pending operations. Now since it is 1, we don't have to do anything. We have to go to the next element. Since when we go to the next element, we have to pop from the queue whatever element that is there with the enter 6. Now when we go to the next element, yeah, flip has become 3 now. When we go to the next elements, we are at the 7. What is the size of stack now? Size of stack is 1 here. Size of stack is 1 here. Current value is 0. Size of stack is odd. Resulting is 1. So after applying pending operation, it has become 1. Since it is behind 1, we don't have to do anything. We can go to next element. Since it is not last element, we are ending here. So this is the termination of the condition. How many inputs we need? 3. So we can do it in order of n time. So this is, we are doing order of n operations, order of n traversal, order of k space for I think in the worst case we'll need order of n space. We might do order of n instructions. So order of n time, order of n space. I think this is better. I think it cannot do better than this. I'll just write it. At mode is standard collections back. Okay. No. Right. And then for I in 0 to start then I have to first check current position. At current position, current value will be nums of I, and then it will be XORed only if current value will be XORed. So it will have only 0 and 1 thread. Let me just try to understand the question one more time. It will only have 0s and 1s, right? So since it will have only going to have 0s and 1s, I'll just say nums of I XOR with 1. We'll XOR with 1 if 2 dot len is mod 2 is 1. Then we'll XOR with 1. Otherwise, then we'll XOR with 1. Otherwise, we'll XOR with 0. Okay. This is the current value. Current value and then current value is equal to 0. Then only we'll just insert a new entry in the queue. Dot push back. Push back will have what? The size of and if I plus k plus k less than or equal to I plus k minus 1 then or less than nums.len, then only you can insert any possible flipping operation. Then we insert a entry in the queue dot push I plus push back I plus 2 k minus 1. Otherwise just say return minus 1. We cannot flip anything. There has to be a flipping operation has to be completed here, and we cannot do anything. We will just return minus 1. And then before we go to the next element, we have to pop. So if while to so I think there need to while if to star run start if let sum say equal to 2 dot pop front 2 dot front, then a equals to I 2 dot pop. Okay, that's it. Only one pop here, but at any case there will not be any loop also. And then we just need to how many times we push you have to count. So move arms to 0 whenever we insert any entry in the whenever we insert into the queue. Now to increment answer plus 1 and then to give the answer as a result. Just compile it. What is it saying? Error? Which error is this? Saying the error expected found. Okay, the error if condition is not correct. If q.len equals to 1 else this and current loop. Let me make it current loop and then I'll just say if q.len. I think this is a precedence problem maybe. and mod 2 encryption. Okay. Oh, there is no then here, so we don't need to write this one. And now it is saying some small stuff. It will make I plus as I32 as I32. It will become as I32. As I32. Pop front. It be pop front. Okay, now it is not happy. Actually, I think use start. Right, it is done here. I think it should work. It's 100%. Thank you all. This is the LD solution. I hope you understood the solution. Just post questions if you want to have any doubts. Just post the questions. I'll happy to answer. Just make this code expandable. So this is the code, final code. Hope everything is good. Thank you. All